Okay, another type of barcodes are two-dimensional barcodes. Using two-dimensional barcodes, we can store more data by using both horizontal and vertical dimensions. In the two-dimensional barcodes, because we have the horizontal and vertical direction, it means that we can store more data than normal UPC barcodes inside of a barcode. One of the two-dimensional barcodes are codes portable data files, PDF, portable data files symbols. As you see here in the figure, the structure of PDF is like a series of short UPC, Universal Products Code symbols that is stacked on top of one another. Now, if you look at here, in the row 1, we have 0. We have 0. Look at here. This is the pattern of 0. 1 black, 2 white, 2 black, 2 white. 1 black, 1 white, 2 black, 2 white. And here we have the 0. In the row 2, we have 9. In the row 3, we have, sorry, in the 9-3, we have 8. All of these short UPCs are stacked on top of each other to produce PDF. A second type of two-dimensional barcodes are quick response code, QR code. This is the example of QR code. These type of barcodes are so popular, and you can see them in many advertisements, business cards, and so on. So, using some special applications on your smartphone, we can scan and read them. We can scan and read these barcodes that have a special pattern, again, because this pattern and this code is two-dimensional. We have store more data than the one-dimensional barcodes. So some factors have to be considered during designing a smartphone camera scanner. An engineer needs to consider the different orientation rates, camera resolutions, and all of the other actually matters that are important in designing these scanners. So, as you see here, to detect the camera image of a QR symbol, there must be at least one pixel that is situated within a white region or black region. The QR region are shown in blue or white. These are the QR regions. And the black nodes are the camera pixel location. Now, for detecting the camera scanners correctly, we have to situate the camera pixel within the inside of the white and black regions. Now, this is the camera with the low resolution. This is the camera for high resolution. So left side image, these two images show ideal registration of camera to symbol, and other images show problems with registration. Okay, sometimes we need to embed secret codes into data files that are difficult to detect. This method is called steganography. Actually, in this method, we try to embed secret code into data file. Why we do that? For protecting our data file, and also for security issues that are so important for us. One example of steganography is digital watermarks that assigns serial numbers to each music or video data file and all of the other types of data files. For example, suppose that you have written an original article. Therefore, to prevent copying your essay, you can use from digital watermark. This technique changes the text copy by shifting particular lines in the vertical or horizontal directions. So, using some programs, we can do that so that it cannot be seen with eyes. So, using this method, each document has a different set of lines that are shifted. These shifted lines are determined by a unique binary code. Now, I want to show you that how can we embed the secret code in a data file. Suppose that we have a secret binary data like 1010. This is our secret binary data that we want to embed it inside of our digital data file. Now, we can insert this data into the first 4 sample values because the binary number of this code is 4. We can insert this data into the first 4 sample values by setting the LSPs equal to the secret value. What was the LSP? Least significant bits. This is the least significant bit of each value. Now, suppose that this is our data file represented by 8-bit sequences. I write my code, my data file here. Look at here, please. My data file is like that, 0. This is my sequence, data sequence. I know that I have 8-bit for each value. 8-bit for each value. Now, first of all, we set all of the LSP, least most significant bit. This is the LSB for each value, LSB, LSB, and LSB. We set all of the LSBs in the data to 0. It means that instead of these bits, I write 0. Instead of this one, I write 0. Instead of this one, again 0, and instead of this one, again 0. After that, I add my secret data with this sequence, What was my data, secret data? My secret data was 1, 0, 1, 0. I add this sequence, this secret data with my data sequence. How? I add 1 with the first 8-bit, 1. How can I represent 1 with 8 bits? 0, 0, 0, 0, 0, 0, 0. For 0, I write 8, 0. For 1, again, 1, 2, 3, 4, 5, 6, 7, 8. And for this one, now I add my secret data with data sequence. What happened? My data, my new data, I add bit by bit. Now, what happened? My data will be 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 0, 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 1, 1, 1, 1, 1, 1, 1, 0. This is my new data sequence. That using digital watermarks embed the secret data into it. Now we can transmit this data. Only we know that at the LSBs of each value we have our secret data. This is my secret data. 1, this is my secret data. This is my secret data. And this is my secret data. Now I could embed my secret data into LSPs of my data file. This is the digital watermarks method or steganography of digital data files.